Yeah, of course you choose the weekend training resource, so you can choose that. Okay, thank you. So you're from here or you're from reside here or?
Sorry, I missed that.
No, you're from here. I mean, are you a Johorian or?
Yeah, I'm staying in Berlin.
Oh, stay in Berlin. Okay. Alright. So yeah, manual, everything is right over there.
Okay, thank you.
Then I just went to washroom. So you'll be here. Yesterday we had another training in sponsor Pulai for 3 days.
Ooh.
So after training finish, we came back and then we set up everything over here.
Thank you very much.
So yeah, my name is Swaran. I'm the training organizer, manager, auditor. Yeah. So we have two company names lah. AS Automation Services and AS Automation System Training Centre (PLT). So this company was established officially established kickstart in 2012 by my boss. He's in 2000 is right over there.
Okay.
Yeah, he's now considered retired as my father. So because now he's 75 already. Yeah, and he succumbed to his stroke. He used to conduct training. So he established this in 2012. His background is instrumentation engineering. He was ex-army, the DUDN, and he was a technician. And then after he completed his service, he's from Kedah, so he completed his service. He came down here to look for a job in Singapore. At that time, in Singapore, job searching demand was very high. Yeah, I'm talking about the 90s, those days.
Yes.
Yeah, so he came here in 1991 and then he got a job in the port. Then he became passionate with PLC. Become very passionate with PLC. The first PLC he touched on was the S5 PLC using DOS base, very old one. DOS base, those are DOS base, very old one. We still have that. There are still companies running with S5. Still got
the components and also the lifespan.
Yeah, the life. If we do advise them convert it, convert to a new one. Still running, but leave it. So after that, he did his instrumentation engineering in Royal Australian Air Force in Australia, and he came down for a job. He did his industrial diploma in industrial automation at Young Poly, and after that, I think he completed his career 35 years already. Like he worked, partners of companies, got a stack of certificate actually. So in 2012, he opened up his company. He actually collaborated with another of his partner. He's a German. He has automation services, TE. That branch is in Singapore, but that one mostly focused on project and consultation and services. Here we mostly focus on training. So in 2012, he established his company. First, we did focus on services project. And then training, we just slowly kickstart. In 2014, we registered ourselves under HRDCorp as a training provider, lesson training provider. And since then until now, we have trained more than 3,000 plus participants. But not only we conduct training for Mitsubishi, we also conduct training for Siemens, TIA portal using S1200 PLC. The Semantic Manager is before TIA portal one, the previous generation, the one using S1300. Mitsubishi. Last time we conduct training for the GX42 model, which is FX3S. Now we have upgraded to GX43. So basically, I give you two manual. This one GX43 and the GX43. So you can play around and know the difference. Because there are still companies using the older model PLCs that is only can use GX42 also. So, and Mitsubishi, Omron got two types, also C series using CX1 and the NX series using Siemens Studio, and the less demanding type of PLC like Kians, Schneider PLC, G Fanuc, G Fanuc and backup PLC also. So we only specialize in PLC and HMI. Okay, so as usual, at the end of the training, certificate will be provided. Digital copy, I email to you. Hard copy on the 5th day, I will give it to you. Okay, and consultation is completely free, which means because you will be holding our certificate, so if you have any problem or what, you can just contact us anytime. But if you expect us to come to your place and do any services for your you don't have to be. Okay, so yeah. And I grab your name and PC and
So there is a balance.
Balance, you can settle now or you can settle later also, okay? If you want to credit transfer, bank transfer, okay, then email will email to you the receipt. Okay. Give me a moment. Then that's it. So right over there, if you need coffee, they want coffee. tea, black coffee, all 3-in-1 you can have hot water already prepared. So you can make yourself feel like home.
Thank you, thank you.
Just for confirmation, normally the IC name. This one print as certificate.
Yeah.
Okay, no, you do that first. You do that first.
Sorry.
No problem. Good coming,
Good morning.
This is Vivian. You can consider him as the second generation trainer. He was completely trained by my boss.
No problem.
Yeah. So when my boss, we had to retire him in 2022. Before that itself, because he joined us in 2015. So whatever projects, services, everything I bring in, I consider him, gain that experience, share it with the participant. So basically that's how we conduct the training. If you need the Wi-Fi password, then this one is right over there.
Okay.
Check my video.
FC5. Is it?
Yeah, one.
Okay.
So, sorry, I just transfer the balance.
Later I will send you the receipt. Okay, so you are from Johor, is it?
Yeah, I'm staying in Berlin.
Oh, Berlin. Oh, okay. The last 2 days, no water.
Yes, problem.
Yeah.
I need to shower at company Singapore.
You working in Singapore?
Yes.
Okay, last time I also stay. No, we use the heat and laptop later.
Oh, okay, so you use the heat.
And later I take.
Yeah, name I see, name address.
Okay.
Name and company for IC, yeah. That's a quick attendance. So the G capital or small capital. Yeah, bro.
Yeah, okay. So you're working in Singapore?
Yes.
Okay, what company?
It's called Santuku BASF.
Oh, what they are doing?
Chemical.
Oh, chemical. Oh, okay.
Actually, it's a little bit joint venture with the BASF.
Oh, okay.
Actually, this Santuku is from Japan, their joint venture. Then help them to produce the H2O2.
Oh, H2O2.
So actually we are we land a place from the factory. Actually, once you go inside, there is a two factory. Actually, our factory is built to help them.
Oh, okay.
But they are doing the sales.
Okay,
They help them to produce
the gas now.
the liquid. H2O2 is to help them to, especially for the wafer fab, to use the chemical to wash the wafer.
Oh, what's the wafer?
More like the bleach, Clorox. More concentrated.
So after they cut the wafer, before they wash,
everything is
polish.
Even the COVID period, the government also use this to kill the
bacteria. Okay. So they are using Mitsubishi.
Yes, because of Japan.
Yeah, of course. So they are using the latest this one lah. The FX5 or Q series.
Q series also have.
Q series.
Q series also have.
Oh, okay.
So Q series because they want to use the HMI.
Yeah, this one also can use HMI.
Yeah, but if no HMI required, they will use the 3 series.
Oh, FX3. Okay. Because normally if not HMI required, it means it's a small system, right? So small system, just the PLC enough. Okay. If a bigger system, then I need an HMI. So bigger system, of course, Q series is.
Because they need the touch screen.
Yes.
That's why great for that.
Okay. So have you done any programming before?
No.
Troubleshooting?
Yes, I'm a technician.
Okay.
I do troubleshooting sensor and in motor.
Okay.
But only once I troubleshoot, heal the PLC side, then start.
Okay.
No PLC.
Okay. Good. So, but we will start from the basic lah, no worries. Okay. So what we do, create a folder. So do you have a laptop?
Yes.
Okay. Never mind, I can keep first. So later on I can install the software in my laptop.
Thank you.
The software. So whenever you have a free time, you can just open, just do some practice. Okay. Okay, so whatever question you have, you just can stop me, can ask me, no problem, because only two of us, right? Say only one class, so just nice.
Thank you for your time.
Yeah, no problem. Because normally weekends those who are working in Singapore, JB, so they prefer weekends. Okay, right. Okay, now you right click here, you click a folder. You have a mouse there. Because yesterday we had a training in Foxconn. So it's a 12 packs. We went there and give the training. So that's why all the PLCs is still inside the box. Okay, right click. I think new. What time you have? Okay, new folder. Okay, and put your name. Okay. So whatever program we do, you can save inside here.
Okay.
So later on, you can copy these files.
Okay.
Okay. Right. Now, we go to GX Works 3. Yes. One. Okay. Can you see? Okay. This one the touch panel manuals lah. Okay. Okay. This one is the manual. This manual.
Okay.
Okay. It's a short copy here. Okay. This one. So it's our company profile. This manual. Jesus 3, and this one is just for you, Jesus. They both the same way. So this manual you have a soft copy. Okay. Then the last one. So later on you want to copy that.
Okay.
Okay. So we open the last one.
The last one is 3.
Not 3, yes. Okay. And close this. Okay, can open the slide. Okay. No, you can see my laser. Open the slide. Yes. Okay. So this training will be Mitsubishi training using FX series. Okay. The software will be GX Works 3. Okay. Enter. Press enter. Okay. So PLC, you know like what is PLC, right? Okay, very simple. Okay, because you do the wiring, everything, right? Okay. But basically PLC is a computer. Okay, similar like a computer. Okay, we have a mouse, keyboard, the USB as an input. Okay, then your display, your speaker is like the output. Okay, so at the background there's the running software, right? So similar concept. So even like our aircon, all that same. So like our aircon, so this will be our input. Like this consider the HMI for example, right? So here you set all the values on and off everything. So inside there there's a PCB board. Okay, receive the signal, then on and off your compressor. So inside there they have a temperature sensor. So it will depend on your set point, right? So let's say you set 25, the temperature sensor will detect 25 degree, then on and off you can open, but rotate the motor, right? Okay, flip the swing, then open the on and off the compressor, right? So that PCB board and PLC also okay, exactly same thing. Okay, but the difference is, for example, let's say this aircon, right? This PCB board, I want to add another compressor. Cannot. Right. I want to add another temperature sensor. Cannot. But PLC, let's say I design a machine. Later on, I want to upgrade the machine. I can upgrade. So that is the main difference between the microcontrollers, the PCB boards, and the PLCs. Okay. So that's why our companies all they using PLC lah. Okay. If you see last times, because I do a lot of projects, small projects, that means like an old system convert to new systems, all that. Then old PLC convert to new PLC, then troubleshooting, all that. So I've done a few projects on, they use a PCB board. So it means they have a machine, it's already programmed in the PCB board. So they buy the board from, let's say, Italy or France, okay, they run. But a simple process only, like a cutting machine, if that one spoil, they need to order again. Because they can modify.
You have to know the program.
Because it's like because it's a board one. So if you want to change also, if they have a IC, you want to change that. So what happened recently, one of my participants, he told me they have the system. He asked me whether I can convert to PLC or not. I said yes, because they have some push buttons, all these the motor valve, all that. So PLC can control. So I tried, just give me the process, the flow. I can create the program for you. Then I can install in your system. Then the program is very simple. So I just you tell me the process, create the program, everything. Then I just install my phone. So last time there's a few machines like that. So that is the main difference between PLC and the board. Okay. So PLC can use anywhere actually. Anywhere, if you want to automate a system, also you can use a PLC. Okay, because nowadays PLC they have a smaller system, smaller PLC, just 600, 700 ringgit, and of course a bigger PLC also. Okay, alright, next. Enter. Okay, so PLC, it means they have a CPU, input, output, all together we call as a programmable logic controller. Okay, so they call CPU lah. Okay, sometimes they call CPU. So like a Q series they call CPU, right? Q CPU. Yeah, so because they have a CPU, then only the input card, output card, everything. Okay. Then inputs, we have a digital inputs and also analog inputs. So like just now you say like you do some wiring like NPN, PNP, all that is a digital inputs. So analog inputs means okay, like a temperature, pressure. So on your side you will have a chemical, right? So means like did you use pH?
Yes, pH,
temperature, then flow.
Yes.
You have a tank, so you will have a level meter, all that. So all that become a analog input because for range, right? Yes. So we give the digital and analog input to the PLC. So CPU will process according to the program. Then it will on and off the output, and on and off the digital output, and send value for the analog output. Okay. So analog output means it can control valve. Like valve, some valve is digital, right? Just open and close. Some valve you can open like 10%, 20%, like in percentage. So that one will be your analog output, like inverter, your motor, okay, your pump, your blower, all that. Okay. So anything can control the like the rotation is an analog output. Okay. Then so this is your PLC side, your hardware side. Okay. then you need the correct software and also the correct cable. Okay, then only you able to upload, download means you take the program and transfer the program and also do some troubleshooting. Okay, because if you don't have the cable, let's say you have everything but don't have cable, then you cannot do anything. You cannot communicate. Okay, because now this PLC is still okay because we're using Ethernet, so can use any Ethernet cable. But last time the FX3 series, they have a special cable. So you need to have that cable. So this one is the FX5. FX5 they use the Ethernet cable.
So that means it's the latest, they're no more using the
Latest modules all using Ethernet.
common.
Yeah, common really. Yeah, all PLC same. Even the Mitsubishi also same. But it's easier because by can communicate. So one port is enough to communicate to multiple systems. So last time like this Mitsubishi, the FX got USB and also the round pin. So if the HMI want to communicate, use the round pin. If PLC want to communicate, use the USB, right? But nowadays one port is enough. So that one port can talk to your PLC. I mean, for your talk to your HMI, can talk to your computer also. So later we will be doing that. Okay. Next. Enter. Okay. So before we go here, so PLC, Mitsubishi, the earliest PLC, they have the software they call is a Madoc. Have you heard about it? Madoc.
No.
So both
Is it something like without computer, but it's a small equipment?
that one we call
One old version.
console, right? The one called console lah. But the console okay because in the console you can change the data everything lah, okay. But there's a computer also can use. Okay, in the computer they use a Madoc, they call Madoc, the software. So last time, the earlier days, our Windows is the blue color window, right? You just can't use the mouse. You just use the arrow, enter, where you put the value.
For S6.
Yeah,
version.
yeah, DOS version. Yes, correct. So this Madoc is DOS version. Okay. So this one is to program because FX. This FX, then they have some name like 32 F, okay, F 32 or something like this. Okay, very hard to find nowadays. That day one guy bring the PLC, this big, but this thick only, like a touch panel lah, like this like this big. I mean this the height and the big this size. Only the PLC, only the
PS4, PS5, the kind of.
yeah, yes, correct. PS4 like PS5. That big only, but only the CPU, no IO card. Only the CPU. Then there's a big connector here to communicate to the PLC, the 25 pin one, the big one. So he said they're using for the cardboard. So they, I think some issue. So they bring here, ask me to check whether the program is still there. Then I see what is this? I never seen before, right? Then I go to Google and check what is this model, and because there's a model lah, it's a F32 something. F32 F60 something. Then I go to Google and find out what software they're using. Then I was thinking Madoc. Okay. Then I try to download the Madoc. Finding cannot get because very old software.
Yes.
Finding luckily I get from one website. Then I download. I can even install Windows 10. So what I do, luckily I have one laptop with Windows XP. So Windows XP supports that. I install. Okay. Then I try to communicate. When I want to back up, cannot because no program loss. So
Yeah,
I
no
say,
point.
no
Program
point.
read loss, no
Yeah,
point.
because the old system, they have like this memory, all the battery, like battery fail, program loss, all that. So after this only they come up with the MailSoft. Right. Under MailSoft, okay, they have GX developer. This one is using the A CPU. Okay. Q CPU they put A mode. Q CPU A mode, then also some FX. FX0, FX1, FX2. Okay? So all these using GX developer. Okay? So after GX developer is the GX works, right? Works 2. GX works 2 they use the Q CPU. Then FX 1 can, I think 0 cannot. FX 1 can 2 and 3. Yeah. Okay. Then actually they have this LCPU or that, but in Malaysia and Singapore they're very rare they're using LCPU because LCPU is a special module for like a CNC machine.
No.
They use this kind of CPUs. Okay, because they support because LCPU they support a lot of motion control. Then GS works 3 now. GS works 3. Yes, some Q series can work. Okay, then FX5 you wanna okay, then RCPU, the latest one. So now actually I mean the QCPU I think QCPU is JSON because inside here you have but you click QCPU automatically open this.
No. The switch to work to.
Switch to work to. Then inside here, when you open, you can see that they return a CPU. But if you click, automatically go in.
Oh, okay.
Yeah, later I show you.
But that means if work 3 can do all, can do with the, can match with all these.
Okay, actually, all this software, right, exactly same. Only graphic is different. Actually, these two these two, actually the graphic is different. And developer is for A series and FX like Then when they created FX works 2, I mean JS works 2, they introduced the FX3 and QCPU. Okay. Then what happened? But inside here, but let's say when you open the software, you see there, okay, there will be Q CPU, FX series, and also A series. But if you click A series, the down there will be a message. It shows Open GX Developer. But in the list is there. But once when you select, it will show that.
You just show, but you need to download.
You must have this one.
Just a reminder only.
Yeah, it's just showing that A series cannot use in GXWorks 2, so you need to download. You need to have this one.
But not means if you've got work 3, then you can control all.
No.
Just remind you.
Okay, this hardware is not compatible on this software. You must use it this one.
Okay.
That's why now, if you want to buy the GXWorks 2 software from Japan, okay, because normally we also buy the software and sell from Mitsubishi. So now, if you want to buy only GXWorks 2, cannot. They don't sell only. Whatever they sell like one set. But the same price only. Last time, I think before GXWorks 3, last time my boss buy because that time I joined in 2015. In 2016, my boss buy the license. Okay, that time is GXWorks 2. So when they buy GXWorks 2, the price is around 5,000. Okay, so inside the CD, HX2 and also HX developer both you have. Now, so last year also I buy one software because my company request. So I request for HX2, they say no. They now no more like only selling HX2, like a one set only.
One package.
One package only. That one also same 5,000 plus only. So when you buy, you will get HX3, HX2, HX developer all in one seat.
Okay.
Like one installation. So when you want to install, it's depend on you which one you want to choose. So like say you are doing more projects on all these models like that, you can install all these three. Why you can install all these three? Because let's say for example, you have one system using A series. Now they say they want to convert to Q series or R series, right? Okay. So you need this program.
Yes.
So if you want to read this program, you need this software.
Yes.
So you take this software, back up the program. From here, you can directly convert to it. So there's an option, just directly convert. After convert, change the PLC model to RCP, do some settings. The day because that day I convert my PLC from ACPU to FX3. So I didn't do programming. Program is already there. So I use the JS developer, backup. I convert to JX2. Then I change to FX series. So when I change to A series FX is A series to Q series, no need to do much programming because programming almost same. Only the hardware need to change.
Yes.
But A series to FX series, because the programming is a bit different. So I do some changes. Okay. Okay. Now they converting all these to RCPU. The day I have one last week. Yeah, last week. So today is 24th. Yeah, last week I have participant from where? I say bilang somewhere. Resonic, the Japanese company. Okay, Japanese company. So they also learn JX3. They also because that's why I remember. So they also learn JX3. Their company now they're using QCPU. QCPU and FX3. Yeah. Okay. So what happened from the Japan? They say change all the QCPU to RCPU because now QCPU no more in production already. They are no more producing the QCPU. Going to stop some of the model. Some of the model they still have. Some of the model they want to stop. So they say from Japan they say better change to RCPU. So that's why these guys come and learn. So they want to know how to do programming because the big machine all the Japanese team will come and do come and change everything. Okay, they say they have in many machines, only two machines these guys need to do by themselves, but small system. So that one is FX3. They want to convert to FX5. So it's already running FX3. So they say, then I say very easy. Just take back up the program and just convert, download to this one, can run it.
Only the hardware need to change.
Of course, after you change.
Yeah.
We need to change. Then they say, okay, then come and learn. Then because after they do some changes, they want to add some. Because they want to have analog. The older system, very simple. The new system, the newer after they want to convert. After they convert, change from here to here, they want to add some additional sensors, everything. So they come and learn all these things. Okay, okay. But this software is heavy. This software need 10 GB space in your laptop. This software and this software is like this one is like 2 GB now, this one 2 GB now. But this one 10 GB space. Very heavy this one. But what happened? This one and this one exactly same the software, but they just change the graphics. But from here to here, the interface still looks like same only. The way we do programming, everything looks like same. The name they use is same, but the settings are there's a lot of settings. They totally
More function.
more functions, more like previously the settings all like old school style, normal just put it old style. Now let's say for example, when you do QCPU, right? You have QCPU. QCPU, then you want to add hard drive.
Yes.
Okay. In GXWorks2, it's just a list only, just a name. Okay, QCPU, okay. Second one is what? Third one is what? Fourth one is what? But here, you can see the graphic. QCPU, then analog card.
Okay.
You can see the graphics.
So, like simulate the whole thing.
Yes. So that's why this software heavy. Last time, this one is just like
Just a name.
one table only. Okay. QCPU, what model? Okay. BI, what model? Okay. DO, what model? Just the number of the name. So the software is not heavy.
More graphic.
So now more on graphics. And also they add more settings on the Ethernet.
Okay.
Because for Ethernet, right? For so more settings. It's actually very because I started from this. Then when I come here, I learn this first. Then this after I know it's very good software. And also the way of programming. Okay, before we go into all this, I'll just give you some idea. The way of programming. This one now it's become like Siemens programming.
Yes, I Siemens also same.
So what happened? Omron also now Omron new one also same pattern. So when I see all these three the main three because I do Omron with all this, I see that all become like a similar kind of programming style. So maybe in the future they like all have the same method of programming. Only that different hardware, different style of programming. Because first I see in Siemens, then they release Omron. Okay, Omron use the same method. They have their old method also same. They have additional. So it depends on you. You want to use the old method or the new one. Which you choose. The old method is still there. The new method of programming is still there. So you want to use which will depend on you which one you want to use. But nice. For me, if you have me, it's nice. Okay, good.
Yeah.
Any question?
No.
Okay. So before we go into programming, we need to know what is computer numbering in PLC because this is very important. Okay. Okay. So all these are computer numbering. So means if let's say those who are doing computer programming, they also learn this. Okay. When we do PLC, we also need to learn this. Okay. Okay. Next. First decimal. So decimal, the normal number every day we use. Like deci is 10. So 0 to 9, 10 to 19, 20 to 29 and so on. Okay. Then we have for hexadecimal. Okay. The hexadecimal is means they have 16 numbers. So they have 0 to 9, A to F. Okay. Can I erase this one?
Yeah.
So you want to take picture or want to take note later, okay? Because why? I like to use the whiteboard to explain. For me, I prefer this. For me, I don't like put everything in the slide. You understand from the slide, no. For me, I need to use this one to explain. Okay. Now, so decimal normal number, right?
Yes.
Actually, later on, the slide will have this one. The 9, okay? Because they have a 10. They call base 10. Okay? Then we have a hexadecimal. Okay, hexadecimal same 0 to 9. Same. Okay? Then A to F. So they have total 16 numbers. Okay? Okay. So if I convert the hexadecimal to decimal, so I will get 10 to 50. Okay? So decimal will be 15. But if I convert the data to hexadecimal, I become F. Okay, then we go to next. Okay, first we see the octal first. Okay, octal, they have 0 to 7 only. So they have 8. Then after that, 10 to 17. Another thing. So if you see, in octal is 17, in hexadecimal is F, in decimal is okay. Okay. Then I will tell you where we will use this one. Okay. Binary means 1 or 0. Okay. So we see, okay, like we connect a sensor, right? Like a PNP sensor to the PLC. If the sensor is on, you can see the light in the PLC on. Okay. So the data, let's say is a PNP, means 24 volt, right? So 24 volt go in, it's power on. Inside the PLC, it becomes 1. Okay. If power off, then it's a sensor off. Inside the PLC becomes 0. Okay. So this one is 1 0 lah. Same goes for your analog also. Let's say your analog is 4 to 20 milliamp, right? Because you have 4 to 20 milliamp, right? 4 to 20 milliamp is there's a range there. Right? When you go to the PLC, inside the PLC, it becomes like one value lah. Like, okay, for example, like Mitsubishi, 20 milliamp means inside the PLC is 4000. Okay, that's the value lah. But for us, okay, we will see 4000. 4000 will be in decimal for us lah, for programmer. But inside the PLC, it will become like 101100 or something in binary. Okay. So, but we don't need to know how to calculate the binary or because why this our laptops all they have a calculator. That calculator we can convert these data from binary to hexa to this one all you can convert. Okay. So the 0 means okay lah, 0 lah, all 0. Then if 15 means like 1 1 1 1 is equal to this. Okay. So what happened for us? We can see 15, but inside the PLC it becomes like 1 1 1, something like that. Okay. So these are the 4 data types we use. Okay. So decimal. Okay, when we use decimal, normal. Okay, all the time we use decimal. Okay. And later on we use timer. Then in the HMI you see some values like pressure value, temperature, all that mostly decimal. Okay. Hexadecimal when we will be using, okay, when we do advanced programming. When we do advanced programming, sometimes, okay, for example, you are controlling inverter. For example, you are controlling an inverter. So let's say this is the PLC, this is the inverter. You connect a communication cable. You want to control this inverter. So let's say you want to set the speed to rotate. When you see inside the manual here, they will tell okay 0 to some number lah. Okay, 4000 hexadecimal. They will put like that. Okay, 4000 means is in hexadecimal. So when we want to do programming in the PLC, we can change the hexadecimal to decimal. Then in the PLC we can do the calculation. So we can send the value. When I send the value inside the PLC, it's 0 to 4000, something like that. Okay, so advanced programming we use this. And other place, Mitsubishi addressing. Addressing means the input for address, right? Input X, output is Y. So Q series, A series, R series. Okay, means CPU type lah, the module type lah. Okay, they use this number for input output. It means the A, Q, R, the input is X0 until 9, XA until XF. The address lah, 16 input. Okay, another 16 input will be X10 mean 10 lah, right? Until X19, X1A until X1F. That is. So Y also same lah. So let's say because it's depend on the number of slot. First one, second one, third one. So let's say the third one is your output. Then Y20 until Y29, Y2A until Y2F. Okay? That is.
Question.
Yes.
Why they cannot start with the 0 anymore?
Can, but it's depend on the where I arrange.
Or followed by the
Yes.
base
Yes.
position.
Yes. Followed by the position. So you cannot means let's say the Y I put in front, then Y becomes 0.
Oh, so can.
Can.
Anyway.
Because the position is you can put any position can. But normally if you want to do like a good practice, input first, then only output, right? But for PLC, it don't get input first or output first. It's depend on inside the PLC. Like just now, if I do the table, right? It's depend on the table only. Okay. This one for this. For FX series or F series, only for FX, they use octal method. Octal method. Okay. For this one is X0 until X7. That's all. Then X10 until X17 and so on. For this one, don't have the slot. Because for like this one, because it's fixed. On top is input, below is output, right? So this one will be Y0 until Y7, Y10 until Y17 and so on. Depend on how many input, how many output. So you see, A series, Q series, the R series, they're using hexadecimal for their addressing. But FX series, they're using octal for addressing. This one need to know. So when we convert from this to this, because when I convert this to this, inside here, there's no A until F. There's no number 8 and number 9 also don't have. So it will become error. So we need to manually one by one we need to change. This is where the difficult part is. If you do one by one the changes. Okay, good. Okay. Next. Enter, please enter. Yeah, this is the table, the same table here. So just you can see the differences. Okay. Next. Okay, this is the how to use the calculator. Okay, so I will just later we try. Okay. Next. Okay. So before we go into here, okay, you can just press the window button. The window below that. No, here. Down there. Yes. Okay. Can.
That window button come out with this.
Okay. Go here. Yes. Calculator. Okay. So it's standard, right? Usually if you click here, yes, and this is program. So we have all this. So anytime you want to change any number, okay, just click these numbers, it will change for you. Like 59, yes.
Okay.
So in decimal is 59, in hexadecimal is 3B. 38,
sorry.
3B, then in octal is 73, in binary is 1111, 1011. Okay. Okay. So later on we will be using also like minimize. Okay. Make it slightly bigger again. Yes. Okay. Now these are the addressing for the FX series for this model. Okay. So they're using X for the input. Can you see they put base 8, right?
Yes.
Base 8 means is octet. If you're using Q series, they will put base 16. Okay. So the total number you have is 1024. For X and Y is up to 256 and 384. Means inputs can support this FX series.
Input can support means 256.
Yes.
Input.
256 to 384 inputs you can put. Means because this one is only a few, right?
Yeah.
Then later on you can add modules. Okay. Then the output also same. Okay. Then this one M is the internal memory. It's the internal relay, right? Okay. Then it's a 10 means they're using normal decimal number, right? Okay, normal decimal number. So it means a memory they have 32,000 memory. Okay. Then latch relay also same, similar. Memory and latch relay also similar, both same. But what is the advantage for latch memory? Is if we power off and on, the memory become 0, but latch memory will be stay on. That is the difference. Okay. Then data register. Okay. This one is just on or off only. Okay. This X input, output, memory, latch memory, all these four is just on or off. But data register means can store value. Can store a value. Okay, let's say you want to put timer value 10 seconds, 20 seconds for 1 hour, 2 hours, like that. Okay. Then timer. Timer also same. You can go up to 1024 timers. ST means accumulation timer. Okay. Normal timer it means okay, you start run, let's say you cut off the signal to timer become 0. But ST timer means when you start, okay, you calculate, when you stop, the value stop. It won't reset. So later all these we try. All these we try and do. Okay. Then we have a counter and long counter. Counter means just count 1, 2, 3. So long counter means bigger values. This normal counter means can go up to 32,000 only. This long counter can go up to, if not mistaken, the value can go up to 2 billion values. Okay. Then this M is internal relay, right? Means is a user defined. Means programmer can put okay M0 is for this, M1 is for this and that. But special relay means Mitsubishi already fixed for you. This M means this is the function. You can change. Like example, the battery status, the error status, all that you want to read up, you can use this. Same for special register. What is the difference? This one is just on off. Here you can get values. Like if you want to get the timer value, then you use this. Okay, can okay. So it means now what is this? These are the addresses that we can use in the FXs. So your A series, Q series also mostly same. Because normally Q series will have additional. Compared to this, we'll have additional, and the numbers also will be bigger numbers because very big PLC, right? So we'll have bigger numbers. Okay. All right. Next. Okay. So this one later is. So now later we see. Okay. Can press escape. Also can. Later we see. That's why I think these two slides, the last slides. Okay. Can escape. Yeah. Okay. Can minimize this. Can minimize this. Okay. So what I want to do, the first thing is I want to back up the file from the PLC to the laptop. Okay, I want to back up first. Okay. So can you see you have a GX Books 3? Here. The software. Yes, that is the software. Okay. Now what we do? Go to online. Can you see read from PLC? Okay, click that. Just click once enough. Okay. Then here you can choose which PLC you want to read. Can you see R CPU, L CPU, FX, Q CPU, FX CPU, all that? Okay. The one we're using is FX5. If you click this one, you click this one, FX CPU. Okay. Clear, okay? You see, you bring this one to slide. You close, or you can close. You see, it go to FX GX Books 2. This one is a GX Books 2. But here it shows that GX Books 3 compatible mode. Because just now you open is different, right?
Yes.
Because the symbol you see here, this picture, this icon, similar to this, correct?
Yes.
It's not showing 3, right? So because I said FX, you automatically open this. That's why I want to show you. Okay, now you can close.
You
Go back to 3. Because you see, 3 means show 3. Okay. Go to online. Read. Yes. FX5, yes. Okay. Okay, wait up. So we are using Ethernet, right? Okay. So this is my laptop adapter. Okay. Okay. So how to know if this one is not? You can right click here. No, here. The earth symbol. The round symbol. Yeah. Right click. Right click. Okay. Network internet setting. Yes. Okay. Then you go down. Okay. Advanced network setting. Ethernet, right? You click here, the Ethernet. Yeah. Okay. So what is the Ethernet name? Intel Ethernet connection. I219, right?
Yes.
Okay. Can minimize this. Yes. So make sure it's correct. Okay. Then you test communication test. Okay. Successfully connected. It's okay.
Yes.
Okay, then here, okay. So just now we did read, right? Read means from the PLC I read. Okay. What you want to read? All. So you select all.
Yeah, right.
Okay. Or execute. Okay, close. Right. Can you close this also? Okay. So the program is under scan and main. Okay, open the main. POU. The first one. Okay, program board. Yes, there's some programming inside. Okay, so this is how you backup lah. Okay, then you can just go to project, save. Yeah, go to desktop, choose your folder, open. Okay, you give it a name. Day one, backup one. Yes. Okay. Okay, good. Okay, that's all. We already done backup. Okay, you can close this. No, no, no. This is down one, down one. Okay. Yes. Okay. So we already backup. So inside got some program lah. So we will get what type of program. Okay, just then if you want to monitor the program, see the program, you can go to online, watch, sorry, monitor mode. Yes. So you can see you can monitor the user. You can see right now. Okay, I adjust the font. It's so small, right? But as we clearly do it's too small. Now actually you can use this one, then you can scroll this. Make it smaller, bigger. Okay, so easy. easier. No need it's more difficult to see. Okay. Okay. So this is how we back up the file.
Okay.
Okay. It means now backup is very simple. Okay. Backup is just go to online, click here, I should just show you. Click, then read that, but no need to click. Okay. Once you click that, okay, the software will ask you for the what is the communication. So is it USB or Ethernet or serial cable? Once you choose the correct one, okay, then it will ask you what are the data you want to back up. So let's say you want to back up only the program. Then you choose only the program. But if you want, but normally backup, we backup all, right? So we backup all. Once we backup, we just save. Then, if you want to see the values, want to monitor what is the problem, everything, then can monitor. If no, just say keep the file. So in case the PLC got issue, the problem, you can use that file. You buy a new PLC, download that. Okay. Right. Any question?
Yeah. Let's say, just how we say, AQR is using the Excel.
Yes.
So, and FX is using the auto.
Yes.
But why they need to do so? Why means is why FX is not using Excel and why AQR is not auto? Is there any reason or?
Okay. There's one reason. Okay, I tell you one. Number one, why they using octal first? I mean, hexadecimal because hexadecimal, if you ask me, it's like a old system. Our old computers, whenever they find a computer, you know, like last time, the computers is like 8-bit, 16-bit, 32-bit, right? Something like that, right? Okay. So what happened? Last time they using 16 bits, they use hexadecimal. So because hexadecimal is 16, but 16 numbers, 16 numbers, 16 numbers. Okay, that's number one reason. That because why? Earlier they come with the A series and Q series or that. Okay. Number one. Number two is okay. What they do? Okay. Q series is a modular type. You have a module for bigger PLCs. Okay. Then FX, okay, I want to use for a smaller system, so make it compact. Okay. So when they design that, then the A series, they have a module, right? So the module like this: CPU, then input output. So they think, okay, now how many input I want to put it here? 16 input or 8 input or 32 input. So what happened? They design, okay, the minimum is 16 input. Because on Mitsubishi they don't for these CPUs, if you see, they don't have 8 inputs. Very rare. I think if they have also, that will be like a special inputs. Mostly 16, 32, 64. So 16 input. So for them it's easier to use these numbers. 16. So then like I said, why just now you asked me why this one not zero? Because I said it's a become slot. So when they come with this type of functions, it's easy to use these numbers. But this one FX is compact, so they can use anything, but they decided to use this one because why? They have a small one also, very small PLC.
I mean, if they want to design FX for Excel, still
Can.
But
So, but they
compact size.
Yeah, compact size because the minimum one also have only 8 inputs.
There's enough, yeah.
Yes.
Because AQR is for
Bigger system.
bigger for more I/O.
Yes. Okay. Okay, you sign.
Double check the line. I see.
Okay, good. Okay. So what we do, we create one program, a simple program. Okay. Before we go for break, we create a simple program. Okay. Go to project, new. Okay. Series is FX5U, type is FX5U, program ladder is in program language is ladder. Click that. So you have a ladder, structure tags, sequential function chart SFC, and also the function block diagram and ladder mix. The last one is the function block and the ladder mix. Okay, so it means that they have a different type of programming. So it depends on us which one you want to use. Okay, you want to do ladder mix. Okay. Okay. Right. Very simple. You go to so when I click, then it will come like this, right? Program body. We create a simple program first. Just a simple program. Before that, we go to device command, the common device command. So X0, right? Okay, you give a name, start, stop.
Start, stop.
Yes, start and stop. No, the first one is start, second one is stop. Sorry. Okay, then you add Y0 here. Y0. Enter. Okay, for Y0, you give a name motor. Okay, enough. Next, you go back to here. So the symbols are normally open, normally close, output, everything is here. Okay, we get a simple program. Put normally open.
Normally open F5.
Yeah, F5. Then we just put it here X0. Okay. Then output you put Y0. Output is F7. Yes. Y0. Okay. So means that if this one on, this one on. If this one off, this one off. So let's say if this is a push button, right? I press, I on the motor, I release, I still want to on the motor, right? So I hold, create a holding pin. So to create a holding pin, I think this. Yes. Y0. Okay. Right. Then you click here. So if I want to, so means I on this, the motor on, I hold here, right? If this one is off, also I still on. Then if I want to off here, normally close X1. Yeah. F6.
Close contact, yes. X1. Okay, yes, that's all enough. But if you want to see the names, go to view. Comment. And then you can answer the problem. Okay, comment display. Yes, so it will be shown like this. Okay, alright. Okay, now once we finish the ladder, or if we do any changes in the ladder, first thing we need to do is go to convert first. Yes. Okay, means it's not like this, look like a gray, right? Must become like this. Means because why? I create a program. I don't know whether the program is the logic I don't care whether it's correct or not. But the programming I do must be correct. Means the like example, when I do this one must be connected here. Okay, then I do normally open, normally close, but no output. Means it's not like not complete. Like, okay. So means if not complete means I click the convert. It will show. It will tell me that okay, it's an error because why your ladder is not complete or wrong data. Okay, all that. Because when I cannot download to PLC wrong, I can download wrong logic can, but wrong, how to say, wrong program I cannot download. Okay, that's why this one they ask you convert first, then only you save. Yeah, no. You save day one, lesson one. Yes, day one, lesson one. Backup, take out, backup. Okay, lesson one. Okay, save. Alright, so we will create multiple lessons. Easy. Okay. So first thing, where after you create a program, convert first, then save, right? Okay, after done, go to online. Okay, go to current connection first. Yes. We need to check our communication first. Okay. Okay. Okay here. Okay. Now go to online again. Write to PLC. Just now we read from the PLC, right?
Yes.
Now we write to PLC. Yes. Okay. What you want to write? Program and parameter can. All also can. But depend lah. Okay. Okay. I will tell you when to take. Wait. Okay. When you are doing a new project, okay, and you are doing a totally new project, even your system also lah, totally new project, or you have the backup. This PLC is new, so you want to transfer this file to HMI. At these two scenario, you choose all. So choose select all lah. Okay. Now inside there's already program already running. Then I take the program, I do a small changes. I add one sensor or I change the normally open to normally close. That one you download only the program. Because why? You do changes in the program. You didn't do the changes in the parameter or global setting anything. Like this, for now, first time downloading. So you can download one. Second time, third time downloading, you just choose which one I change, I download that.
If let's say I forget
straight away download all. Okay, whatever. Okay, actually nothing will happen. But in case, For example, this PLC already running, all good. Okay, so you added one sensor. So what you do, you want to add a sensor, you want to add the sensor inside the program. So you back up the file. When you back up all. Okay, so you close. Close this one. Okay. So means you back up the file. Okay, let's say inside the file is look like this. Okay. Then you change this one from normally open to normally closed. Okay, done. Then what you need, example, you just go to module configuration. Here. Yeah, open. Yeah, okay. The module configuration means you can add the modules. Okay. So what you do, you just go and see that. You didn't do any changes, but you just go and see here. Okay. Then go to parameter. Go to system parameter. Okay. Then you go and do some. You didn't do some settings. You didn't change anything, but you go and see. By mistake you change something, but you didn't notice.
Oh, okay.
Right. So you didn't notice. So when you download, let's say suddenly become error. So you don't know where is the problem. So it's always better to just download it.
Just save whatever you did, but not everything.
Yes,
Because
yes.
maybe some careless
Mistake can happen. Yes.
you change it all.
Yeah. Just one small mistake can suddenly stop the PLC. Yeah, then you want to find out what's the problem, issue. So normally what I practice because I go to a company to troubleshoot. So sometimes company call me and go troubleshoot. What I practice is I back up that file, I put aside. I don't touch. I agree and back up. Or that backup file I save as different version. Something like that. So now I have two backup files. One is the original one, another one is I want to edit. So I do some edit because I want to test that. Edit, okay, download, okay, I ask them can work or not. Edit and download, ask them. So then I know what is the problem. So I settle the problem, but I do some edit, right? I don't know what is the edit I need. Sometimes I forget. Sometimes I forget to take note. What I do, I have the original one downloaded. That's what I practice. Because the original one I don't touch. The second one is for me to just do some changes because why? Why I do that? Because that machine, I don't know how the machine works. That is the first time I see the machine. Okay, so they will tell me, okay, this motor not working. So what I do, I go to the program, I see. I sometimes I try to bypass any sensors or that. I try to bypass and see whether the problem is with the motor or sensor. Just to double check only. So sometimes when I do that, sometimes I forget to take note. Normally I will take note what I did. Sometimes I forget to take note. So once okay, then I see motor problem. So then I consider motor, check everything. Okay. Once I settle, I come back to here. I forget to where I do changes.
So there's a backup.
So there's a backup. So that's what I. So that's the best way.
Okay.
Yeah. Close. Okay. Now go to online. Write to PLC. Now the new project and select one.
Okay.
Yeah. Execute. Yes. Yes to all. New project is okay. Hardware configuration project. Okay. Close. Okay. Here we are. Okay. There's a message. Message shows that you download parameter, right? So after download, you need to reset the parameter. Reset the CPU. Okay, how to reset? Okay, there's a switch there. Okay. So after download, now we can you see there's power on but not running. Arrow is there, right? This arrow button is on top is run, middle is stop. You just toggle down, it's a reset. When you press down, it will show like this, right? Just then leave it. Just run. So this one you need to do if you download the parameter. It's a parameter, right? But if you download only the program, no need to do this.
Okay.
Okay? Can close? Okay. So now download ready, everything is okay. Go to online, monitor mode. Okay. So now want to test lah, right? So you can just click here. Because later on we do some wiring like connect this button. Okay. For now, you click here. No, not double click. Just then you press the shift button and also enter together. Shift and enter. Yes. Yes, you can see. It's on the output. Okay, you shift enter again to off the button. Yes. So it's still holding, right?
Yeah.
Okay. Yes. Now you on the stop button. Shift enter. Okay. Shift enter. Yes. Because shift enter is on. Again, shift enter is. Okay. Any question? No. Okay. Yeah. Okay. So we go for a break. Then after the break we can continue. So if you want a coffee or tea, you can drink.
Thank you.
No, no. Okay. So what we do? We add a timer. Okay, add a timer. Okay. So if I want to edit, so just now we new project, then we convert the ladder, then we download, right? Then we monitor. Okay. If you want to edit, go to project. No, sorry. Edit. Ladder. Edit. Ladder edit mode. Right mode. Yes. So then only I can add some, edit the program. Okay. So here you click normally open. Okay. Moto Y0. Okay. Then for timer must use the F7. So timer is T. So T0 space. Okay, how many seconds you want? So let's say I want 10 seconds. I need to put K 100. Yes. Yep. Okay. Okay. So we go up. Okay. Start motor, then motor on. Okay, means when I start motor on, right? Then when the motor on, timer will start to count. Okay. So once we reach the 10 second, the T0 will trigger. Okay. So what I can do, I can use the T0 here to cut off my motor. So you put the F6 normally close. Yes. T0. Okay. Alright. Okay, go to convert. 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 The first one. Yeah. Okay. Then go to save first. Yeah, the save. Okay, go to online. Write to PLC. Okay. You deselect. Yeah. Okay, just the program now. Here. Yes, that one enough. Okay. Execute. Yes. Yes, tomorrow. Close. Yes. Okay, close. Okay. Now, this download, I need to reset the PLC. Yes. Okay. Now, I want to test, so I go to online, monitor. Okay. This one, you shift enter 2 times. Okay, you click here, shift enter 2 times means on and off. Yes. So timer will start to count. After reach 100, motor will run. Yes. Okay. Okay. Now, can I erase this?
Yeah.
Okay, so here we will be learning, we will learn how to do projects lah. Okay, how to do programs first. Then at the same time, normally what I do, my style is I teach something, I give you a small project. Teach something, give you. So the main idea is I want you to be familiar with the software. Okay, download, upload, online changes, because you are, after this training you are not going straight away go do a project, right? Okay, because you want to know how to use the software, number one. Then then how to use the main basic things. Then only you need to know how to troubleshoot. Because your program is already ready. So you just need to know how to read the program, troubleshoot, right? This thing. So we first we learn how to do project, everything. Then lastly we learn how to troubleshoot. Because once you learn all the basic function, then troubleshoot will be easier for you. Okay. Now that is my style easier for me. Okay. Now so I give you okay. Now why the timer then? Okay. So when I start, then the motor, okay. Then I stop. So this one you know right why? Because latching, right?
Yes.
Then I use the motor to on a timer, right?
Yes.
Okay. So why I use the motor? Why I didn't use the start? Because timer is when I give the signal, I must give a continuous signal. Then only can count. If halfway stop, timer will cut off. You try and see. The start button, you on and off. Okay, the stop button is on. Can you see? The timer halfway stop. So means here I cannot put the start button, right? Why? Because when I press, the timer can run. When I release, the timer reset. So that's why I use the motor. Okay. Now for timer, this one is the input. Okay, this is the address, the timer address. Okay, this is the value. Okay. Okay. So once the timer finish 10 seconds, timer will give you output, right? The output also same. The T0 is the output. So this is the input. Then, so that is why after 10 seconds, the T0 will become 1. So I use the T0 here to off the motor. Let's say I want to off the first motor and on the second motor. For example, let's say I have 2 motors. I start first motor 10 seconds, after that second motor off. So I can use the same T0 to on motor number 2 and latching. So this latching is depend on the program. Sometimes you need to latch, sometimes you need to latch. Okay. So means the same T0, here I use normally first, here I use normally. Okay. So sometimes the participant will confuse. You know the push button, right? Start button. Right? Okay, the start button is, let's say, the physical button, like this button. Let's say it's a normally open button. Because for NO or NC, right? Let's say it's an NO button, normally open. Means when you press, the input on. If PLC get the signal, the input will on. Inside the PLC, the start button, the start. Okay, this one is the, let's say, X0, right? Yes. Why X0? Because the push button is pointed to X0. Okay. Now, this start button I can use as a normally open or normally closed also in the program. Physical button is normally open, but in the program I can use as normally open or normally closed. But sometimes by participant they will confuse. Hey, why this one is normally open, but in the program is normally closed? Why suddenly here normally open, this place normally closed? Sometimes they confuse that, but that is the logic. Okay? At this time, right? You see, here I use normally closed, here I use normally open. Same time, right? Okay, why? Because here I want to cut off the latching because I want to off the motor. Here I want to energize the motor. So that is the reason. Okay? That's number one. Okay, why 100? Right? Okay, because this value is 1 is equal to 100 milliseconds. The value. So if 100 means is 10,000 millisecond lah, which is 10 seconds. So very easy lah. If you want to put any timer, add a zero at the back. Finish. Okay. Now, so you see, normally when we do program, we will be using three things. That is, want to edit, we go to right mode. Right. Go to right mode. Want to edit something like okay. After edit, we convert. Okay. Then after download, we monitor. Okay, got three, right? Okay. Actually, these three got shortcuts. That is, if you want to go to right, is F2. Okay. After finish the writing, then want to convert is F4. Then after convert, after download, want to monitor is F3. Okay, good. So you can use the shortcut. Okay, now what I want is this one done, right? Now try to add this one. That is the same timer on Moto 2. So your Moto 2 you use Y1. Okay? Y1. Then use the same stop button. Same stop button and use that. So we try. So I start first Moto on, after that this one. Okay, try this. So first go to want to edit, right? Want to edit the program, go to right F2. Yes. The working one. Apa? Beautiful.
So there is a forget where to look for the star store or
Yes, that is device command, common device command. Yes.
one is for two. Onward.
Yes. Okay.
Three. Something is saying. Now I try to
Okay, the stop button you off first. Actually, you on already, you didn't off.
stop button.
Chip enter again. Yes. Because normally close, right? You must see the blue color. Okay, now you start on off. Now off the start button. Why not to okay. Okay, try never. Okay.
Try again.
Chip enter on off button.
Using 30.
Now again. can.
I think not working.
So when you do mistakes, so we can learn something. Right? So we see what is the problem. But if you see the logic is look like correct, right?
Yes.
Go down.
Maybe like the T0 is not working.
Yeah. Okay. So means I go up. Means I start. Okay. One. So the T0. After timer is cut off. So after the timer, this motor is off, right?
Yes.
It means the T0 is working.
Yes.
But here is not giving the supply.
Yes.
Okay. Number one, what we do? Okay, we check. What we do? We check whether the program in my laptop and program in the PLC is same or not. Okay. Okay, go to online. Okay, that one we call verify with PLC. Yes. Okay, just verify the program enough. Yeah, here also see. Okay, so you see, this one is day one, lesson one. Is your laptop. FX5U is your PLC.
Laptop.
The PLC. Okay. Execute. Close. Wait. Can you see mismatch?
Yes.
Right? Okay, it will show. Okay, you double click the mismatch. Okay, so you see here, down there. Mismatch means red color. Source only means in your laptop only is blue color. In the PLC only means it's a green color. Okay, it means this line, right? That is the T0.
Okay.
T0 or means this is all Y1. ANI is normally closed.
Okay.
Stop and output is Y1, right?
Yes.
Is in your laptop only. Inside the PLC don't have. It means you didn't download. That's why it's not working. I think because after you convert, you straight away monitor.
Almost.
Because you add this one, you need to download that.
Yes.
But you didn't download. That's why.
So download.
Need to write to PLC.
Alright.
Okay, now you close this one, close the verify. Check. Yes. Okay. So means you just now you add this one, after convert, you're supposed to write to PLC. But you straight away go to monitor. Yeah. Go to online. Now write to PLC. Okay, go to program is execute. Yes. Yes to all. Okay, close. Yes. Okay, close. Okay. Now you shift enter on and off. Can work now?
Yes.
So just now the problem is you didn't download. Okay, good.
Yes.
Okay, now can you add? Okay, so you already added here. I want you to make it like turn into this into a small project. Okay. Now, what I want to do? Let's say we do a small project. Let's say we have a start button. Then I have a stop button. Then what else? Let's say I am Moto 1, Moto 2, then Moto 3, right? Moto 1, Moto 2, Moto 3. So when I start, motor 1 run for 10 seconds, right? Right, now run for 10 seconds, after that, motor 2 on.
Yes.
So we already until here done.
Yes.
Okay, now what I want you to try to complete this part, that is, motor 2 run for 12 seconds. After that, motor 2 off, motor 3 on. Motor 3 on for, let's say, 15 seconds. Then motor 3 off. The similar process. Okay? So any of the motor is on, I press stop, the motor off. Okay, like this lah. So means now I press stop. If this motor is running, off will off. If this motor is running, this one will off. Okay. So we already done until motor 2. So try to add a timer. Check first with motor 2, then add the motor 3, then add the timer. Okay? You try and see.
The motor 3 will stop after
50 seconds. That's all. Then there's no other motor to on. Can actually can try and see. Just explore. Okay, sometime you let's say for example sometime okay, you write like this, right? Okay. Example sometimes you already until here, okay. Sometimes we cannot imagine whether the motor is on or not, right? But we haven't complete. No problem. What you do? You just straight away download. You download the PLC, you just press start and monitor. Okay, not working. But the T0 can on this, but cannot on this. Why? Because T0 is like on and off. So that's it. Right? Okay, you need to put the stop button. Moto 2 no need to put stop button. Okay, but this one you cannot imagine. Because PLC need to imagine, but
Yes.
so you cannot imagine what you do, no problem, just download. Download, test, okay. Now motor 2 can work, okay. Now put the stop button, after that. Slowly one by one, you have no problem. Okay, try.
Also, bro, I think until entry after 15 seconds, I think not cut off.
Okay, why not cut off?
I think what command I should use.
Okay, to cut off motor 1, right? To cut off motor 1, what command I give?
Normally,
Timer, right? Okay, to cut off motor 2, what command I give? Stop and also timer 1. Right now. Yes, the timer need to add because so the motor always will follow the command from the stop and also the timer. Maybe Thailand. Can? Cannot. Okay, never mind. We see why. This one company got issue. They have one PLC, I mean HMI. What happened? This one got battery, right?
Yes.
The battery
Lifespan.
so battery library. So when they power off on the program got
They're supposed to change
change the battery when it's
before
power
off the
on.
bulb.
Yes. So what happened? Program does. Luckily they have this one. So they sent to us. So I back up from here, download here.
Oh, the reason,
There's another one is similar one. Luckily they have.
lucky.
Lucky if no finish.
My third one keep running. Something.
Okay, good. If something is wrong, okay, you go up. So this one is okay. Second one, okay. You see, motor 2 are not off. Why?
Yes, yes.
Why motor 2 not off? So after the timer, motor 2 should off, right?
Yes.
So you need to add the timer like yes.
Yeah. That's the time. Yeah, normally
Close.
T1.
Yes. But go to edit right mode first.
Sorry, the one. Right one.
Right mode. Edit. Because now it's monitor mode. Go to edit. Ladder edit mode. Right mode. Number 2. Yes. So
Close T1.
yep.
Forward again.
Okay.
I should forward
Yes.
something. CPU control will change my online information.
Okay, yes. And why? I think no. I think you click F2. Okay, now convert. Oh, okay. Not online. No. I think there's something wrong. Okay. Go to online.
Okay.
Go to monitor. You go to edit. Ladder edit mode. No. Ladder edit down. Right. Yeah. Okay. Now go to convert.
Convert.
Wait. It's supposed to be convert. Why it become online program change? Go to setting. Convert. Back to default. Okay. Yes. Okay. 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 Forward. Okay. Just now it become online changes. That's what problem. Okay. Right. Yes. Okay.
Now come the auto one is
Yeah, because the start button you haven't off, so it's repeating.
okay.
See, Edward?
Thanks.
Yes, okay. Now, let's say you want to repeat, continue, right? If you want what you put in. Let's say after finish this, want to contact the first module. How? You try it.
So sorry again, how to label the strong stop here? What's the command?
No, it's already labeled. I think you go to view,
Use
comment display. Let's display the comment. Okay.
I'm not sure that it's correct. Not the right way.
Yes.
People should follow.
Okay. But your idea is correct, but it's not the correct way lah. So your idea is when the T2 is off, you want to on the start button, right? Okay. Now we cannot on the input. Okay. Okay. Can I erase all this?
Yeah.
Okay. So X is the input, right?
Yeah.
Okay. So it means X is how to say, you cannot write any value to the X. Means you only can read. So means you can only can use as a normally open or normally closed. Right? So this one it won't go, but it won't give you error. You see? It won't give you error, but it won't go. Okay. So, but your idea is correct. That is when I start the motor one, right? So change. This one is the stop. This one is your T0 main. Then the last motor is what? Your Y2, T2, 850, right? Your idea is after this timer, I want that. Okay. Now, if let's say you have another motor number 4, okay, what you do? You will use T2 motor 4, correct?
Yes.
This is what you do, right? But let me finish. Okay. T2 motor 4, okay. But we don't have motor 4, but we want to use motor 1. Okay, so T2 motor 1. Okay. But we cannot do 2 times like this. Means already on top I already used this one is oil, right? This one is the oil. So this is the oil, so already I use here. So if I use here, what happens? It becomes error. But T2 want to on this one. So what I do, I add here. Similar to my start button. So here I don't need. So what happens? When I start, motor on, latch, right? Run after the timer, motor will off. And when Y2 on, timer after this timer, now this one will on. So this one will give the signal. So it means that's why if you see our logic, right, for so many like this. So line is very big. Why? Because for so many means this one means start or the timer 2 also can on the motor. Let's say later I have a sensor to on the motor. For example, I put it here.
Another one.
Yes, sensor 2, for example. Something like that.
Yes.
So the best way is this one can, but Omron will give, Mitsubishi will give you error. If you do like this, Mitsubishi give you error. Omron and Bradley. Omron and Bradley will give you, if you do 2 times like this, will show you duplicate output. But won't give you error, it will give you warning only. Okay? But Siemens won't give you any error or anyone. It means you can do, actually this one can do, but if you must do a correct program. Okay, like this example, but I think here cannot. Let me try and see. Okay, we go to edit mode, F2. Yep. Okay, you change this one to double click. Double click, change. Normally close, change to normally open. Here you can change the first one. Yes. Okay, you double click here. The X0 change to Y0. No, Y0. This is O. Okay. Convert. Okay. So you see, no error. No error. Okay. But it won't work. The program won't work. Okay, why? Okay. You need to understand how the program works. Okay. How the program works. PLC will read the program left to right and top to bottom. This is how the PLC will read the program. Okay? Now, let's say I do like this. So, but PLC will read in milliseconds. Every millisecond, okay, finish, go up, finish, go up, finish, go up. So, very fast. Very fast. Okay. So, when you press start button, okay, this is normally closed, this is normally closed.
Yes.
Okay, when you press that button, the signal goes on the motor, then latch the motor like this, okay? Then you off it.
Yes.
Okay. Then what happens? PLC go to the second line, third line, fourth line, fifth line, sixth line. It come here. If you see, okay, timer not yet on. So the motor is supposed to off. So what happened? Here the motor is off. Okay. No, motor. I mean, it's still on lah. But what happened? Since my PLC very fast, right? So inside the program, it become like on, here on, here off, here on, here off, on off, on off, on off. So physically, we only see off. We can see it's on. Okay. But if you do correct program, then can go. What is the correct program is? T1, I mean latch. So what happened is, when I start this one on, right?
Yes.
Here also on. So what happened? When PLC come here, okay, on. Here also on. Okay. Repeat. Okay. After the timer, here off, right? So it off, then off. Okay. Then motor 2, motor 3. Okay. After this timer activate, this motor on, right? On. Here on. Okay. Then here also on. Here also on. Okay. We try and see. Then only you understand. Okay. Now, without this, we try. We try to on this one and see whether it can work or not. Okay. You download this, right to PLC. Okay, can you start? Can you see the motor not on, right? But the timer is working, can you see?
Yes.
Why? Like I said, on off, on off, on off, on off. So what happened? Physically, your motor won't be off. Okay, got it? Okay, you go to edit mode. You off the start button, you off. No means it's like that.
So, say another.
Yeah, now we do this way.
Okay.
One more and test. You see. You think yes. Now you not running. What? What? Go up. Okay, you check your PLC, is it run?
No.
Okay. You stop and run. The PLC. The small switch, the small switch there, you must stop. Yeah. Just no need this, just stop. Go to it. Okay. If I can. Now can go. Okay, shift enter again. Now can go. Can you see? Right.
Yes.
So you do a small mistake, the program won't work properly. Okay. That's why it doesn't give you any error. Right. Doesn't give you any error.
So that means this is another way of program or follow.
Yeah, follow this one means okay.
Both of them can.
Yeah, you can use this. You can use this. Okay, now the debate is which one is good? Because both you can use both, right?
The top one is good.
Yes.
Because you use sometimes you don't know whether people do another one or not.
Yeah, because this one very
Yeah,
clear.
duplicate. You know whether duplicate.
Okay, number one. can do this one. You see that the PLC doesn't give you any error. It's working perfectly, no problem, all good. But if you want to troubleshoot the problem, you know why? Because normally when we want to troubleshoot, what we do, we will check the output. So why we troubleshoot? Okay, one of the output is not working. So we go to the, let's say the motor one not working. Okay, we open the program, we see where is the motor one. Now the motor one, I have here and here. So now I don't know which, let's say this one don't have. So now I don't know which logic is problem here. This line or this line. So difficult to troubleshoot. So the best way is using this one. So if the motor is problem, so I only need to focus here.
Yes.
That's why it doesn't give you error, because sometimes you see in the YouTube video, sometimes some of the guys, because in YouTube also many videos PLC programming. So some of the guys they say you cannot use. Not like this, they say you cannot use. It's not like you can use, but if it's someone want to troubleshoot, it will be difficult. That's the only thing. And another one is not a good programming now, because you see, if we do manufacturing line, so we need to follow the GMP, like good manufacturing practice. So programming also same. Programming also they have some few criteria for good programming practice. One of these is this one. Another one is so when you do like address, I mean when you put a name, like put a clear name, proper name, that is good programming practice. When you arrange your program correctly, that is good programming. You didn't do like Moto 3 first, Moto 1, Moto 2, like that. 1, 2, 3, then you do so that one all become a good programming practice. So this is one of them. Okay, okay. Okay, good. Right. So we go for a break. tahu lah. We go for break. After the break, we come and connect some input outputs. Then it will be easier for us. So no more like on and off. Just can test. Okay. Okay.
Thank you. I'm at 1:30.
Yeah. Nama saya tahu.
Ada cuci eksklusif. Ini kira-kira tension boleh. Nah, tahu lah 10 jam. Yang kita break kita tahu, tapi ada yang 10 jam. So itu stable lagi. Kita boleh 10 jam. Ya nah. Boleh 10 jam. Internet. Boleh terus dulu kasih. Boleh 10. Divide. So dia itu body dah ada. Screw chapter amat kelas saja. Agak itu ni. Boleh kata maksimum dia ada komando boleh tidak malu. What's that order? Okay.
Really, waiting for. Okay. Right. So you have your laptop. You have laptop?
Yeah.
You want the software?
Yeah, please.
Okay. Give it to me. I will start. Huawei.
Yeah, only. Long time ago, my daughter is a game, play game.
You have the more?
Yes.
This one is Windows what?
10. Yes, you know,
Yes, yes.
you download all the games.
And your son is
My daughter
Oh,
not become her computer, her laptop already. Actually borrow her to
so now you have to
Zoom
follow lah.
because sometimes the school do online study, right?
Yeah.
One she take it like her laptop already.
So now you have to borrow from her.
Yeah. Even want to ask her my password, forget my password already.
Okay, wait. Can you come here? Can you the IP levels of no, I want to turn off the views.
Turn off the viewer.
Any protection. Scan.
Scan. Is the Trojan. Protect.
Protect.
Private protect. Great. Is the covering.
Look for protection.
It's a setting. Just delete this thing.
Okay. I also have the same thing. Drives the activity protection. This is a protection.
It's a Trojan check.
I'm an activity.
Check.
Check.
Scan. Check. Pass. Pass also. People check. Check. Okay, without this thing also okay.
Yeah, I tried to install. Okay.
No, not enough space. And maybe some water games or how many gig left? Only 3 gig left.
No. This one is free. This one is because I think because the games all check. I just break the because it's only one
Or I
time
bring it tomorrow, so tonight I can do something.
and because these two right actually need one SSD only.
Mm.
Normally we
Yes,
just
yes.
make it two right.
Yes.
Maybe I try to increase this one. Increase the GB
Or
and
bring some.
yeah, some
I should check yesterday night. This morning, they gave it to me, and okay, I believe some feel some space.
now. So we do some wiring.
Yeah.
Because I installed this one. So later on, we go back, we practice, see.
Let's say practice without PLC still okay.
Okay, because for simulation.
Mm. From the website, I saw there's some old PLCs selling.
Yeah. Okay, so now what we do some wire, okay? So the PLC we put it here, okay? Then we connect 24 power supply, okay? And this one for the input switches, okay? From the input I connect here, okay? From here later go to the input, this one is output, okay? So for the switches, right, you need to give the power signal, right?
Yes.
From the power supply, right? That is this one, input common. So this one go to the switch, look one by one, all the switches, and one by one it goes here.
Yeah.
And same also for this one. This one go to the LAN, then one by one it pointed to here. So later this one and this one, you can design whether 24 volt or 0 volt, you just can take from here. So later you connect here 124 or 0 volt.
Yeah.
So this one loop. Okay. Then I draw the PLC.
Just break.
Let's see, can
No,
any
it's okay.
separate?
It's okay.
No, can put separate.
Can maybe yes, I do here.
Use this first.
Thank you.
Good. Now, see, this input, the PLC input will have a SS.
Yeah.
Input side, right? You have a SS. SS. So here got the 0 and 24, right? 0 and 24 you take and you connect it together also. Power up. SS, so let's say SS is 0 volt, your input is 24, right? The output is related. Okay, and what do is power out. Okay, now, so SS X0, X1, X2, X3. So, but here I draw only 4, but you connect all the 6 inputs, so easier. So we have the 24 volt, the power supply, right? The module. I mean the terminal block, right? Okay. So from the terminal block, I take one cable, connect to the access. Okay. Then this one all from the input go to the terminal block. The terminal block go to the switches, right? Okay, I have a terminal block for the switches, and all the switch I already looked, right, and I already connected to input COM. That's one small one. Then that input COM we connect to the power supply. Let's say the SS is 24 volt, this one is 0 volt. So this is the sink NPN.
Yeah.
If this one is 0 volt, this one is 24 volt. So it's a source.
Okay.
Yes. Because you are doing this while again, sometimes some people they don't know. They confuse.
Yeah.
Source and sink is different. PNP and pin is different. Totally two different things. Sometimes. Okay. Now output. So for output, is a this one is a relay type now. Okay. So you have a COM, then Y0, Y1, Y2, Y3. Okay. So same thing. We use the same power supply. Okay. You connect to the COM. Let's say depend lah how many COM, because we have 2-3 COMs, right? Okay. Then this output all I connected to the terminal block, and then that terminal block go to the LAN. Then all the LAN I loop, I connected to a terminal block out COM, and this terminal block I connected to power supply. So very simple. Since this is a relay, so you can connect even 230 also can, right?
Yes.
230 AC. Then the other side will be neutral. This one 24 DC, 0 DC. Then this is 0 DC. Then this is 24. Okay. But since this LAN, so we can't use this LAN.
Yes.
You can use either this one or this one. Okay. Okay. So you do the wiring. I give you the wires. So here you have. Here you have.
What are we?
Yeah, that's big now. So this one can be fixed again. Oh.
Need to check. Oh.
So your SS
Thinking.
key to mix is 24 lah.
24. Yeah.
So your input is
Negative.
your com
Come is positive. 24.
positive and this one must be negative. Because your com is
Positive.
positive, right? Means so the output will be positive. Output going to here is positive, right?
That's what. Yeah.
Okay. Then
Of this.
this one must be negative. Your output com.
Output count is negative.
The looping.
This is negative.
Yeah. No, your com is 24, right? For the output. The com is 24.
Count is 24, yes.
So the loop table must be 0 volt.
Ah. That's it.
So this one must connect to 0. And the rest. So you connect 6 inputs, right? 6 inputs is output, huh?
Yes.
Okay. So easier to test. Can you put the password?
Couple components. This one is access to positive in this side is 0, correct?
Yeah.
So that means just now what my mistake is here is positive, here should be negative.
Yeah.
Then to the positive
Yes,
side.
correct.
So, check the bill. Okay, now if let's say I'm choosing Syncade, so the deposit is correct. But this one is it independent? It means
that one is independent.
so either
Can.
both side I can.
Yes, both sides can.
Okay.
It's not related to this.
Okay.
This one can be anything.
Opposite side.
Opposite sides can.
Same like here lah.
Same like here lah. But only like sink or sauce lah. Also something similar, but it's not necessarily must be. Here sink means there also must
Here
be.
is depends on the what kind of sensor.
Yeah, what kind of sensor.
Here is nothing.
Here is nothing. That one also depend on what kind of output we want to use. Want to go to relays or contactor, lamp. Okay, so what I did is I from the old one, from the D drive, I take 30 GB, try to put in the C drive, cannot.
Okay.
So what I did, I created another drive. That drive I put inside the C.
It's a E drive.
No, I didn't put anything.
Okay.
But it's inside the C drive.
That means put
In the C drive.
drive.
So I try to install that.
Okay.
Because I don't want to, actually I can install in the D drive. The software can install in the D drive. So what happened? I installed in the D drive, some of the, because when I install software, it will install so many files, right? Some of the file will go to the C drive. So sometimes it crash. So it's kind of that.
Thank you. Thank you.
Okay, now you power on, you go monitor and you can test just the program just now.
Do I still need to do this?
Yeah, want to monitor need to read. Yes. Okay, can you
It's running here, but the screen side never show you.
monitor?
Sometimes it's,
You click monitor, cannot.
it means I cannot see the counter is running from here.
Monitor. Go to online,
My monitor,
monitor mode.
monitor,
Okay. I see the blue color. Can I?
yeah, yeah.
It's good. Okay. Now, you save this one. So now we can go down.
See.
That's it. Okay. Now we create a new project. You see some other functions. New project. Go to project, new. That's CPU. Okay. Okay, good. Okay, now we go to device. Device comment. Okay, common device. Then the key here, start, stop. Okay, then the third one, maybe we can use what reset. Okay, then the first three button is a push button, right? Fourth button is the selected switch. So for X3, X4, X5, you can put like sensor 1, sensor 2, sensor 3. You want GX goes to? You want GX goes to?
Yes, please.
Yeah, I see.
Because currently my company all use GX2.
GX2. When I install, I see whether I can change.
So next time, let's say you want to buy some PLC like Mitsubishi from yours, or is it cheaper in the market?
Yeah, I can get cheaper PLCs.
Because currently my company all orders from Singapore, some more from GST, this and that.
Yeah.
Then actually they also I thinking like or possible next time if there is some orders into
Order, you can order. Yeah, we have good resale spare parts as well.
You think Mitsubishi is the most popular or the Siemens is the most popular in the market? Most people use prefer. I've heard it's Siemens, right? Is it because of the not easy to operate or very
No, because Siemens one is it can last long. Not can last long, it's reliable. Even Mitsubishi also say. The thing is, Siemens is more to means you can arrange your program very nicely. You can arrange your program, but Mitsubishi cannot do that. Can arrange, but normally not all the model can do it. Q series can do, FX series cannot do it. Means FX series has you must write the whole program in this like one program one that the whole one you need to do that. But Siemens not that. You can arrange, you can create multiple programs. Then they have function blocks. Like this later we will be using the function blocks. Okay? And this one, right, you have X, Y, M, P, then one here, L, latch relay, then timer for T, router, so many, right? Siemens on the X, Y, so X for I for input, Q for output, memory, data block, it's four only. But within these four, you can get used as different types.
You mean less command?
Less one, but each one like this one is X, only is like on or off only.
Yes.
But Siemens I can be on and off, you can use, or can be a value, can store value, all that. So, but depend lah. Like Europe machine, of course, they prefer Siemens.
Yeah, of course.
Germany, right? Germany. But if you see other than Siemens in Europe, I think some other PLC like even Schneider also is the programming wise. If you see nowadays all similar to Siemens. Japanese PLC means Mitsubishi and Omron. So many Kiels, Delta, Panasonic.
Why price comparable? Is it Siemens more cheaper?
Siemens or no? Siemens expensive.
More expensive.
Siemens expensive compared to let's say the Q series is a modular type. Okay, so let's say the CPU how much? Like 4,000, 5,000. But Siemens, the CPU can go to 7,000, 8,000, depend. But Siemens, no, Mitsubishi, smaller module will have a higher memory. Let's say let's say this module, this CPU can go up to 64 KB memory, for example. Let's say they're selling for 6,000. But Siemens 64 KB memory, they will sell at 10,000, 12,000 CPU. That's the difference. Pricing is a bit higher compared to Mitsubishi. But they have big models, small model. Small model is cheaper. Actually, this one cheaper. This Siemens, so it's a new model, 1,200.
It's cheaper than
Mitsubishi. This Mitsubishi will, if you buy a new one, will cost you around last time 2,700 from Siemens, from Mitsubishi. But that one I buy from Siemens, 1,900.
So like that, market rate people will go for this one.
Yeah.
Siemens is more easy to program and the price is
Yeah.
better than
Yes.
Mitsubishi.
And a lot of things can do. Can connect to, can do IoT program, connect to the phone, all that directly. This one can, but you need like third-party software to do that. Yeah, so you need some interface, some software to do this. Siemens directly can. Yes. Still got a document. What do you do? You can bring to computer shop. Because they can back up first all your data in the C. Then they rearrange your C drive, then they can.
Because we had just delete some old files.
Yeah, this one because to install both the software you need 20 GB free. So you need 20 GB free. Then I can install because the data D right is 300 GB. It's wasted there. So someone got 200 GB, 230 GB plus is free. Why you want to waste that? Maybe you can bring to computer shop, ask them to rearrange
From
what information is
D is more little more than C or
yeah, because you see the C drive are 120 GB only. You allocate the allocation. Then your D drive is around 300. Then 30 GB like. This one you have 7 GB only free. This one you have 330 GB free. Not easy one. So maybe you can give some here lah, maybe up, maybe you can put C drive.
And what it means if you install G drive, E drive, maybe afraid the thing will crash.
No, it can install because I tried to choose D drive can install. It can install normally. Normally PLC software must install a C only.
Oh, well,
Yeah. So can you at least take some
transfer something to the C lah.
then D maybe you can put like 200 GB lah enough. So want to say find some files here then you can. Because I think if you delete some soft files also, you won't even not much. Okay. So but I leave the software inside.
Okay.
It's in the D drive for me. I might borrow because still actually also for training.
Yes.
So you have still 1 week. Or if you want a laptop like that, we sell also laptops. Refurbished lah.
Yeah.
Not new one. Just refurbished only can use for PLC programming.
How much?
1,200, 2,400. Depend which because this one is how many GB RAM? 16 GB RAM. Right?
Yeah.
Yeah, like
16, 251.
25 GB. This one very less.
Yeah.
But you see, I don't have this one. I don't have D drive. I only have C drive. So all inside here only. I'm not using for any others. Only PLC software. So you see how many software this one running. Siemens, Mitsubishi, then LLD, Mitsubishi HMI, Schneider, Siemens, all here. I only for PLC. Basic, this one, the price is 30,000. He's selling 1,200. So when you increase the GB, the price will increase. But that one you can just install all the software, play. Okay. Now go for output. Output say here need to change to Y0.
Oh.
Can I erase this one?
Yeah.
Yeah. Okay. Enter. So Y0 until Y1. Okay. We give some outputs lah. Let's say motor 1, motor 2, motor 3, motor 4, motor 5. One, two, three, four, okay. Now we go to program body. Program body. Yes, open. Now you put normally open X0. Okay. command display. Command display escape. Then click here. Okay, output F7. Yes. F7. No. Close. Answer. Okay. F8. Choose F8. Okay. Now. So it's a start. Start X0. Then I want to set Y0. Okay, Y0 is your motor 1, right? Okay. Set Y0 means is what? Okay, like just now we do like this, right? X0, Y0. It's a coil, right? Okay, it should be like this, huh? Okay, this one we call coil. Okay, like a relay, right? Okay, because why PLC is developed from relay systems. Right, because before PLC they was using relays, timers, all that. Okay, so they use coil. This one is they use set. It means this one they call set coil. Set coil. It means you just give one signal, like one pulse. It will always set, always on. Similar to I do like this. Like means this program is similar to this. Okay. So if I want to off the set, means if I set, I need to reset. So if I want to off, I need to reset Y0. Then only the motor can off. So who going to reset? Stop button I can use so X1. So now I use normally open because when I press, the signal go in. Right. So when I press, reset. Here I use the same X1 but normally close because when I press, I want to cut off. Okay. So we do this one. We just type set Y0. Okay. Yes. So we want to reset, we need to put the next one. Next one. No, not latch. Yes, normal open. Yes. Okay. You convert, download and test. You off. Now you can press the button. Yes. You see, like you just on and off, right? It's always on. Now you on the second one. Reset. Already off. So you no need to latch like this. Okay. So it's another way of programming, another way of the output. Okay. So for this one, let's see. I want to do the project similar like just now, previous program.
Okay.
Start. 3 motor, right? Okay. Same thing, same thing. So means so I start, I stop, I leave it like. So when Y0 on, say T0 K100. Okay, now after the timer, I want to off the motor, right?
Yes.
So means I need to reset like right. Okay. So I take the stop and put it down somewhere else. Stop. I reset Y0. So what I do, I start motor on, then the motor on a timer, then the timer, once the timer is okay, now I reset Y0. At the same time, let's say I want to on another motor, I just draw one line down. This one is set Y1, similar as now, the previous program. First motor on, 10 seconds, then first motor off, second motor on. Same thing. I start, first motor on. So I use the motor to run a timer. After the timer, the motor 1 off, motor 2 on. Then if I want to do timer for motor 2, similar like this. Okay? But if I want to press stop, but this one you can draw. You can draw. Okay? How to draw is just put one line here. You put your mouse here. You use the control CTRL plus the arrow, up arrow, down arrow. So if you want to draw down, right. If you want to erase, go left, go up. Something like that. Okay. Now, if I press stop, I want to off the motor 1 and also motor 2. Right?
Yes.
Both. So I can do like this. Reset Y1, motor 2. So means same process but different type of program.
Yes.
Okay, try it. So you go to right mode, F2, just edit. Right.
the stock no need, right?
Stop it.
You need to write up.
Yeah, then only easy to stop lah. If no,
Okay. No, without stock.
try using. Too big, you can use control scroll. So you can see. understand the set,
Yes.
set and reset. So set and reset similar to what to say, the coil similar to coil, but no need to latch. So what happens is you need multiple rounds. You need many rounds. So one round to on, one round to stop. So if normal coil means the same round start stop you can do. That is the main job. Okay? And any question?
No.
Okay, we go for break. After the break, we try to do one project. So I show you how to create project. First, how to do the flowchart. From the flowchart, create a program. And then I give you one project. We try to. So you want a coffee or tea? Is it the room temperature is okay or hot?
Okay.
Okay. Okay. Now, so this project you say last year, keep aside, then you can create new projects. Okay. Okay. So normally I will use this project as the first project. Okay. So we already covered normally open, normally close, call, timer, set, reset, right? Normally open, normally close, call, the output, timer, set, reset.
Yes.
Okay. So we can do one project. Okay. So now the project. Okay. Before we go into project, normally how we do project? Okay, what are the things we need? So we need two things. Number one is the I/O list, the input and the output that we are going to use. Number two is the flowchart. Okay. So let's say I create a simple program. The I/O is okay. The start x0, stop x1, then the moto y0, moto 2 y1. Okay, similar program just now I do. Okay, but I show you with the flowchart. Okay, now so the flowchart actually the flowchart is like this. They have two symbols. This is the condition. This one is the condition, and this one is the function. Okay, means condition means okay, like what I think, like press the button, the sensor detect the temperature reach high, the level reach high. So all that is a condition. The function is what? Okay, the motor is energized, the motor is start, the pump is on, the pump is off, the valve is open, the valve is closed, something like that. So that is the function. What I do. So the condition is okay, I get the signal. Okay, I do this one. So what I do, let's say I make it a simple one like this one. They're like the previous one, start stop with a timer. I start. Okay. When I press that button, motor 1 is on. Okay. That's all, finish. Okay. At the same time, I want to on a timer. Okay. That is any timer. So let's say, so since this is a Mitsubishi, so I just put T0 lah. Okay. Timer, let's say 10 seconds. So timer will give you the output. Okay. So after the timer, means once the timer give me the output, so I don't off the motor. Okay. Just leave it, the motor on. I on the motor number 2. Okay, motor number 2. And motor number 2 will on for, let's say, 10 seconds or so. Then, once the timer is already reached 10 seconds, then this timer will motor 1 and motor 2 both off. Means I start first motor energized after 10 seconds, after 10 seconds, second motor energized after 10 seconds, yes, both motor off. So you see, I start means the condition, the function is motor need to on, must on timer also. Then once the timer finish, timer give me the output. I use the output to on motor number 2 and also timer. Then timer will give me the output, so I use the timer to off motor number 1 and motor number 2. Okay, so stop button I make it simple. Okay, when I stop, both the motor 1 and also the motor 2 are off. Can see? Can see? Okay. So means both the motor off lah. Now I do a program by using this flowchart only. Okay, normally when we have a flowchart, like 70% of your program is already done. The balance 30% is when we test only, then only we know. Okay, as for example, okay, here I need to latch. So this one I need to put normally close or something like that. Okay, we try. So I start. Okay, motor on. Right. Okay. say this is the coil, motor 1. Okay. Do I need to latch? Okay. Here it will show, correct? But do I need to latch? Yes, because it's a push button.
Yes.
Okay. Motor 1. Okay. Now, at the same time, the same start button need to on the timer.
Yes.
Right? Okay. Timer, 10 seconds, right? But we know that start button cannot on the timer. So we can use the motor. But you see, but when someone gives me the flow chart, they won't tell you motor on the timer.
Yeah.
They will tell you I start motor on, at the same time timer also on. So when we do program, we need to understand. So we need to know that. Okay. Finish? Done. So this one done. 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 Okay. Now the timer motor 2 on. Okay. Timer motor 2. Okay. Do I need to latch motor 2? Actually, no need.
Yeah, it's not a button.
Yeah, because no, one is not a button. Another one is because once the motor on, this one will, once after 10 seconds, this one will be like always on. It's not like on and off.
Oh.
Because if I put T0 here, then I need to latch. Because why? After the timer, motor cut off, timer will reset. Right? So I need to latch here. But now I'm not using this frame.
Yes.
So I don't need to latch.
Okay.
Okay? Okay. So timer, motor on. Okay. Then the same timer on timer 1. Can I on? Yes, I can. Okay. So I use the
Motor 2.
motor 2 also can, timer also can. It's up to you. Okay. So but you can use motor 2. Motor 2. P1. Okay, 100. Okay. Finish. Then the timer must off motor 1 and motor 2, right? Okay. So if I off this one, right? Means I put T1 here, I off this motor, right?
Yes.
Right. You see, I don't need to put T1 for motor number 2 here. I don't need to put.
Yes.
Correct. Because why? Because I off this.
Off, everything will come.
Yes. If I off this one, motor off, timer off, and timer off, motor 2 also off. So actually, if I put also nothing, no wrong. But no need to put also.
Yes.
Okay. Then for stop button. Okay. So when I stop, both motor off. Same thing. The stop I put it here is enough already. I don't need to put here. So that's how. So isn't that done? So anything is need to add there, because when we do testing, then only we know. Anything need to add. Maybe we don't know. Maybe now we see it look like all okay, but when we test, we okay. When we test, maybe we need a stop button here. When we test, maybe we need a latch here. We don't know. But when we test, we know. But you see, from the flow chart, I can create a program ready.
Yeah.
So you see, all this one will be my interlocks. See, start, timer 0, timer 1, stop button. All will be interlock. You see, start, timer 1, stop button, timer 0, all interlocks. Okay. For this one is different case. This one is not interlock right. Then motor 1, timer, motor 2, timer. This will be my output side. So you see, motor 1, timer, motor 2, timer. Okay? Yeah. Any question? Okay, because I want to come up with a simple project, one project. So same thing, I will describe the project, then I will list down the input output, I will do the flowchart, then you try to do it. Okay? Can I I erase? Yeah, okay.
Okay.
Yep. Okay. Okay. So your system,
Yeah.
in your machine, do you have any tank? You have tank.
Then we have inverter, pump,
Okay. So tank is to for what? The tank.
tank is to dilute the concentrate H2O2. We got one product only H2O2. So they come in concentrate, then we mix with pure water, so take the percentage
Okay.
to
Okay. Actually, very good. That project now. But we do something similar now. But later on, maybe on the last day, because for that we need to learn on analog programming, analog alarm. So once we do that, then we can come up with the project. So you get an idea how your system works, what are the program they do in the PLC already. Because let's say if you have a tank, you have a concentrate H2O2 will come in, then you add your water, then you need to mix.
yes.
To mix, then you need to get the percentage. So how you measure the percentage?
Normally they are take a sample and send to the instrument.
Okay.
They will come up with all the
Percentage lah, the values lah.
the values
Okay. So means okay. So I get the idea. It means they already do some experiment that how many liter of water need to add,
yes.
all that, and how long need to do that already.
Yes.
So once you finish the process, they take a sample, check is it the concentration is correct or not.
Yes.
Okay. So means before that they already do the experiment. Okay. So they will check pH value, temperature.
No, temperature no need. The one after mix, only what is the any contamination, what is the particle inside.
Okay.
Or if it was with the spec, then it's okay. If without the spec, then maybe need to do something.
Maybe we need to add something lah.
Yeah.
Okay. So we do something.
Of course, there is a process that they call raising. Raising is to weigh something like a particle like the iron, whatever, they extract out all the not unnecessary things to make it more pure or something like that. So with that thing, they are with they need a chiller to cool down the process to make the thing, because once they are mixed with the resin, they become heat. Very hot. So they need a cool water to process the thing. Then that's why you say any temperature, yes.
Yes,
But the final is to mix up only. The final product go to the mixing tank. That means really take out everything, extract everything, and go to the mixing tank. Then the final is to add water until you get the percentage, and final check the product in the spec. Then it's okay.
So we can do something similar projects. Make it like of course I originally very big. Make it simple one. We try to understand. So you get the idea how they do. So I do something similar here, but no analog inputs outputs. So we have let's say we have a tank. Okay. So let's say we have okay. So valve A, valve B, pump, okay. Then a mixer lah. So this one chemical coming here, a chemical coming here, mix, then after mix, pump out. That's all. Okay. Okay. So for this, because normally tank means we have the level meter, right?
Yes.
What's the level sensor? Okay. Level sensor. So level sensor is an analog. Correct?
It's not.
Yours is not analog. Just a high level, low level.
Yeah,
Okay, okay. Because sometimes they will have a level transmitter to get okay, what is that. Or sometimes you can just.
Actually, the one also have different tanks.
Yeah, maybe. Okay. So for now, we use the high level and low level. Okay. Then this machine have a start button and stop button. Okay. So how it works is when I press start, valve A is on. Okay. So it will start to fill, right? Once you reach the low level, so now we don't have the actual tank, right? So you need to imagine.
Yes.
Okay. So when you start, okay, you just imagine, okay, water level rising, hit the low level. So you have the selector switch, right? On low level. Okay. Then, so once I hit the low level, I will on a timer because I want to stop here. 10 seconds. Okay. So I want to stop here, 10 seconds. Then, so this one, so this is a chemical A, right? After 10 seconds, valve A will off, valve B will off. Okay, then start to fill. Okay, now until reach the high level. Once I reach the high level, valve B will off, mixer will on. Mixer run for 15 seconds, similar to the start of the project. Run for 15 seconds. After that, mixer off, pump will on. So it will pump out all everything. Okay. So when pump on, first high level will off. Then after few seconds, then low level will off. So when high level, low level off ready, your pump also off. Okay? Okay? So first, the IO one. Okay. Start, stop, low level, high level.
Yes.
So we use the push buttons. So we have the X0, X1. Low level, high level, we use the selector switch. Okay. So X2 not used. So X3, X4. So X2 not used. Okay. Then for the output, we have valve A, valve B, mixer, output. So output no problem, Y0, Y1, Y2, Y3. Okay. Now the flow chart. Yes. So first, when I press start, valve A on. Okay. That's all finished, right?
Yes.
I start valve A on to reach the low level. Okay. So when low level trigger on, I on a timer. T0, 10 seconds.
Yes.
Once T0 reach, I off the valve A off, valve B on. So valve A off, valve B on. So valve B on until high level, right?
Yes.
So when high level on, valve B off first.
Okay.
Mixer on, right?
Yes.
Mixer on at the same time, timer on, right? Okay. So the high level will on the timer. Then once the timer reach, so mixer will off, right? Mixer off, pump on. Okay? Then when pump on, it means high level, low level will off, right? So when high level, low level off, the pump also will off. Okay? That's all. So for stop button, we make it simple lah. That is when stop, like the emergency stop lah, everything off. So while we mixer up, so easy to test. Easy to test because once we finish, maybe we can change the stop. Maybe it means when I stop, but it continue finish the cycle, then only stop. That one later can do lah. Okay. Alright. Okay. Now, before you start, you create a new project lah. New project. Okay. Then you go to the comment. Give all the comments. Okay. But now, when you want to do, right, of course, you write some program, then you download, you test. All okay, then you continue. So you do that way. Means okay, I start valve A on, right? I stop here. At the same time, I add the stop button for valve A. I test. All okay or not? Okay, good. Okay, next. Low level, on the timer. When the timer done, valve A off. Okay. Stop until here. Test. All okay? Okay, done. Then the timer on the valve B, high level of the valve B. Then once okay, then every time one output on off, okay, you stop there. Test. So it will be easier for you. Okay, okay. Okay, try. Any question you can ask me. Good, good. Yes, yes.
So, later I bring the battery, the battery working now. I bring the battery tomorrow we can settle.
Yeah.
Tomorrow settle, then I'm coming here. Only one battery, the other battery, the town today only hour. So that will take time, but he said down is okay. That one, he will come and pick it up later on. Okay, boss.
Good.
Today they want me a little bit of green for me.
It's okay.
Ada pun mesti.
Is that okay?
Just now the first one, not really as we do it.
Cannot. Something easy.
Not finished yet. 5, 2, 1, 2. Okay, I'm not.
Okay, never mind. So whatever you want to say first, you also can.
Copy.
Tomorrow is really a time problem.
Today was about.
Yeah, of course. Because today my main idea is you play with the software. That's why I give you small project. Then when you play, do wrong or you do correct, no problem. You play with the software, you be comfortable with the software. So then tomorrow morning you come and see. So we open your project, you see, maybe one or two things only need to change. So we do then finish. then we can continue with other functions. Okay, good. Right. So whatever you done, you just save.
Save that.
Save it.
So we need to shut down.
Okay. But actually, weekend class, I mean, 1-to-1 is okay lah. But the best is if you ask me, like 2% or 3%.
Yes. Also,
They also, because they have different type of question.
yes.
So their understanding is different. So you also can learn. So maybe when they do project, they do some mistakes. So at the same time, you can learn that also.
Yes.
That's the best one. I normally I don't take many people. I maximum take 10. But 10 also 2% share one hardware. So maximum is 5 hardware. So means maximum 5 group. But I prefer like 3 or 4 maximum. That's the best one. So no distance. Just training that they can learn. The company normally send 10 packs, 8 packs.
Understand.
Yeah. But nowadays, no. Last time different. Last time our company sent 10 packs, but for basic only. Like 2 days, 3 days training only. So they don't learn advanced level. But like this year, since like last year mid until this year, company send like 3 packs or 2 packs, but for advanced training. So they reduce the packs, they increase the quantity, in the quality of the
You need someone to guide the others.
Yes, so one is guide, but another one is totally understand. Don't want many people go training, but only 1 or 2% get the knowledge, right?
Now, for my company, it's actually a small company, not just one product.
Yeah.
20 over people. Then the senior engineer, the previous one, really left. That's why they hired me. Okay. Well, the first day I walked into the company, then I found nobody know about electrical. There is no electrical engineering. Even the engineer, there is engineer. Just promote to senior, not the one really. Also, they don't know about the AC, DC, no idea at all, zero. Even the first day they come to ask me whether I know how to change.
But
yeah. So I feel very funny as a company, how can you not need be very good, at least you know something, right? That's why I found this PLC sensor, a lot of things they do. Means after once they know I have a little bit basic on the
sensors, yeah.
So now everything with the power,
Electrical side,
electrical side, I was not for me to troubleshoot, fix the thing. And always one troubleshoot come to the PLC, then I stop.
Then you stop,
I don't know what to do. Actually, actually I also invite them come to learn together. Maybe not interested. Maybe also quite difficult for them if they don't know what is DC and AC.
Yeah, of course. Actually, PLC, before you come, you need to know basic electric.
Yes.
You know basic. Okay, how the bulb, how this light is on.
Yes.
So
yes.
how does thing work? So the light is there. It's from the switch, then the neutral goes there. The basic things are sensor, how the sensor works.
Yes.
24 DC plus minus. That's not enough already. You need to go into 3-phase, all of it.
Yes.
That's the basic.
Simple PNP at the end they always use.
Yes.
Then I found before I joined, they are sourcing anything need to replace, they try to get back the same thing. The machine already, the company already over 20 years.
Okay.
So something you cannot find again.
Absolutely.
So they just don't know what to do. They don't know how to get even they don't know how to read the spec. What actually
spec, okay. The part numbers, everything.
Yes. They must get the original and the same brand. If not, they are lost.
They lost, yes.
That is the problem. That's why currently I learned a lot of it. That's why just now I asked you a question.
Yeah.
If there is a PLC, we see better price here over here. I believe in Malaysia because the GST over there is quite
Yeah. They're cheaper.
yeah. Yes. Then anything happen, let's say currently the problem is on the PLC down and what just now actually we happened before
The battery.
the power trip cause there is a battery nobody
Notice.
nobody noticed there is a battery somehow
Yes.
until they get someone to step in and settle everything but very
Yeah.
yeah but in Singapore side then now it depends on one group one company only.
So anything problem you have to call them.
Yeah, then like the day what the same thing happened like the software already gone and it's a Christmas period. Yeah, we need to wait for 2 weeks until the person come back and solve the problem.
Choice.
So for me, I want to learn more.
Yeah,
I want
at
to
least you can.
I try to.
I think the basic, the simple thing you can solve first.
Yes.
Maybe very, let's say there's a programming involved, something very advanced, then you can solve them. Like simple thing, let's say you have the backup, you already back up and keep suddenly power trip first.
Now this is
You
the
can use the
problem.
backup.
This is the problem.
Ah.
We have no backup at all.
Yes.
Then the problem now actually I want to ask also, once I get the software, is it easy for me to extract get back all recover the means from the PLC? Then maybe they have some password.
If they have the password, then there's a problem.
If without password, there is not a problem.
No problem.
For those maybe the software with license this and that.
No issue. Because the software I can give you is my license. So it's original. It's not a crack version or something. So we can use no problem. Thing is, like just like only you did backup, right? So no password means just very smooth. Go in. You got password, then you ask for password. You can crack the password, but the problem is there's a software to do that. So that software I don't have. The software in the internet they have, but they are some people they're selling the software very expensive. Not very expensive lah. Consider cheap lah. I think $120 something. So maybe in the future I need to get one software and keep. So how many PLC you have?
Well, there's a Q version and FX version. Quite a lot. If I say Q, I think 4 to 5.
Okay.
FX also somewhere there.
Okay. So you can do some backup, then keep the files and everything. So during backup, you know whether which one got password, no password. Okay. So I can tell you which cable, where to buy the cable. Even here also sell the cables. So get the software, get a cable, just do the backup and keep. So let's say even you want to convert the PLC, even the data loss. So it's easy. You have a backup.
We talk to my management side, so
Yeah.
say that cannot depend on one
Yeah.
one company. They also know about that. So they never take action or do nothing. That's why I learn first.
Yeah.
They don't know everything. So next time
You can tell that.
yeah.
Next time, another thing is, okay, let's say the guy who come and solve, right? So next time when he solve, you can be there so you can know what they are doing.
Yes.
Sometimes they do very good.
Although this party also all the PLC is not done by them also.
Yeah, of course.
That means I thought all the PLC is programming by them. Got one or two machine, once they come over, they say this one is not under their program. They are trying to help me. That means previously there is another.
There's another supplier.
Yeah. If if not all the machine is under them, the programming, I think we can do others.
Yeah, of
Both
course.
come in really. Because the management worry, anything happen, A will say B is the one to do, B say A is the one to do,
Yeah.
all push away,
Yeah.
come to the end, nobody want to take responsibility.
Yeah.
That's why they are afraid to get another
Any
party.
other party, yes. They also want
What their concern.
because because those they are the ones supply machine, so they know what is the issue, how to solve the issue. Let's say if another guy come, you try to solve, cannot solve, then he say, okay, I cannot solve, you go back, you go back to them and they say, you call other person already, I cannot solve. I know. So, okay, never mind. Continue tomorrow.
Thank you.
Alright. The books all can give it here.
Okay. We'll see you tomorrow again.
Yeah.
Thank you for the time.
Yeah, sure. You want a job? Where you stay?
Sleep. Beliefs.
Oh, Belibis what? Because I always, my aunties, last time I stay in Kosa. Okay. Then now I.
Kosa is the one behind the DP, right?
No.
Kosa is where
Near the Chinese temple there.
My sister-in-law is over there.
Then I have my cousin, my auntie is there in Belibis 2. Belibis 2. I always come there.
See you tomorrow.
Yeah, sure.
Thank you.
Alright.
How did you?